Hello my friends, and welcome back to the You Can Do TV channel. How do millions of cars conquer vast oceans, rolling from factory gates to global showrooms in a breathtaking logistical dance? The process of loading and unloading vehicles onto ships for transoceanic transport is a spectacle of precision, with the drive-on method as its heart-pounding centerpiece. Annually, 15 to 25 million cars, valued at $600 minus 800 billion United States dollars, cross seas on roll-on/roll-off RoRo ships. In this case, You Can Do TV channel is assuming $30,000 to $40,000 per car. At vibrant ports like Yokohama, Japan, or Bremerhaven, Germany, thousands of cars, from $20,000 sedans to $100,000 luxury SUVs, line up on sprawling docks, gleaming under the sun. RoRo ships, up to 200 meters long and able to carry 2,000 to 8,000 vehicles, dock with ramps ready. Each ship's cargo, worth up to $200 million, demands flawless coordination. The drive-on method is the star of this operation, a scene straight out of action-packed videos. Skilled drivers, with pinpoint accuracy, steer cars from the dock up a wide, hydraulic ramp at the ship's stern or side, leading to multi-level decks. The ramp hums with activity as vehicles stream aboard, parked just centimeters apart to maximize space. Each car is secured with nylon lashings or wheel chocks to brave ocean turbulence. Ports like Yokohama can load 3,000 to 5,000 cars in 12 to 24 hours, with drivers navigating tight spaces like a choreographed ballet. Every vehicle's position is logged, ensuring a cargo worth millions is trackable. This mesmerizing flow, often captured on video, showcases the pulse of global trade. Over 2 to 4 weeks, ships sail optimized routes to hubs like Los Angeles or Rotterdam, safeguarding their $600 minus 800 billion annual cargo. Crews monitor holds, protecting vehicles from shifting during storms, ensuring each car arrives pristine. Unloading process. At the destination, drivers guide cars down ramps onto the dock, reversing the loading spectacle. Inspectors check for damage, preserving each vehicle's value. Major ports, processing 1 to 2 million cars yearly, dispatch them to dealerships via rail or truck. This electrifying process, driven by human skill and the iconic drive-on method, delivers cars worldwide, powering economies and sparking dreams. In the following sections, we will look in more detail at the technical aspects, as well as the specialized vehicles and machinery required to load and unload cars and other types of goods. The process of loading 11 Mini's car transporter at the Oxford Mini plant in the UK is designed to efficiently transport multiple vehicles using a specialized hydraulic system. This system includes a hydraulic ramp, which is crucial for raising and lowering the deck to allow vehicles to be loaded and unloaded smoothly. The transporter can hold up to 11 mini cars at a time, significantly improving the efficiency of vehicle delivery. The hydraulic lift mechanism utilizes pumps and cylinders to elevate the deck, giving precise control over the loading and unloading process. Once the deck is raised, vehicles are driven onto the transporter and securely locked in place using specialized mechanisms to prevent movement during transit. The transporter features a robust drive system that includes heavy-duty wheels and axle assemblies, capable of supporting a full load, which can exceed 25 tons in total weight. This ensures stability and smooth operation, even when the transporter is fully loaded. Safety is a top priority, with advanced braking systems to keep the transporter stable while loading and while in transit. Emergency stop valves are built into the hydraulic system to ensure safety in case of malfunctions. The operator controls the system via an advanced control panel, allowing them to adjust the ramp angle, raise and lower the deck, and secure vehicles efficiently. This combination of hydraulic power, safety features, and a reliable drive system ensures that the Oxford Mini plant can transport vehicles safely and efficiently, providing timely deliveries to various destinations while maintaining high operational standards. The RoRo terminal operates by offloading vehicles from ships using specialized ramps. Automated cranes, forklifts, and AGVs transport the vehicles through storage areas. Machines handle the sorting, tracking, and loading for onward transportation, while human operators coordinate and ensure smooth operations. The integration of technology enhances efficiency and safety. Euchre Car Carriers uses advanced lifting and handling systems for breakbulk transportation. Roll trailers, Samson heavy lift trailers, and cassette systems enable smooth, secure cargo movement. Instead of traditional lifting, wheel-based transport minimizes risks and maximizes efficiency. Adjustable decks and reinforced ramps accommodate oversized machinery, handling loads up to 300 tons. This method ensures seamless loading, optimized space usage, and reduced damage risk. Euchre's innovative solutions guarantee safe, efficient delivery across global shipping routes, meeting diverse industry demands with precision. The container handler lifts vehicles like the Mercedes AMG G63 into a 40-foot container by using a lifting capacity of up to 45 tons with a maximum lift height of 6 to 7 meters. It operates efficiently with a small turning radius and advanced control systems. Cars are transported using roll-on/roll-off RoRo ships by simply driving them onto the vessel via built-in ramps. Once on board, they are securely lashed below deck to protect them from sea weather. At the destination port, the cars are driven off. This method ensures safety, efficiency, and cost-effectiveness in global vehicle shipping. The OOCL Hong Kong, the world's largest container ship, has a carrying capacity of 21,413 TEU and measures 399.87 meters in length. At the port of Felixstowe, the ship uses advanced cranes and automated systems to efficiently load and unload containers. These machines handle cargo, including vehicles, with precision, utilizing specialized lifting techniques to ensure safe and fast operations. The entire process maximizes efficiency and minimizes downtime. Car shipping in the USA with Direct Express Inc. involves using a 45HC container, known for its large capacity and efficient design. The container measures 13.7 meters in length, 2.4 meters in width, and 2.9 meters in height. It has a capacity of 86.1 cubic meters, providing ample space for transporting vehicles. The process ensures safe, timely delivery with secure loading and unloading systems, leveraging advanced logistics and reliable transport networks. Unloading a BNSF intermodal train involves specialized gantry cranes, lifting containers from rail cars to trucks or storage areas. Operators align spreader bars, secure containers, and transport them efficiently. For trailers, piggyback ramps facilitate unloading. The process ensures seamless cargo transfer, optimizing efficiency, reducing handling time, and supporting the fast-paced logistics network. The Taylor X1000 lift truck operates with a 388 HP Volvo engine, a 5-speed Dana TE30 transmission, and a 15 FT Ultra VU mast, handling up to 100,000 pounds efficiently. The Mega Swing system revolutionizes intermodal transport by enabling semi-trailers to be loaded onto railway wagons without cranes. The wagon features a rotating platform that pivots outward, lowering to ground level. A truck backs the semi-trailer onto the platform, which then swings back into position. This hydraulic-operated system ensures quick and secure loading within minutes. Designed for craneable and non-craneable trailers, MegaSwing increases efficiency, reduces costs, and promotes sustainable freight transport by seamlessly integrating road and rail logistics. Cargo handlers are vital in logistics, managing the loading, unloading, sorting, and transportation of goods. They use specialized equipment like forklifts and cranes, ensure safety, and track inventory. Their efficiency is crucial to timely delivery, improving operational flow, and reducing delays.
And that's the way it's done.
The process of loading and unloading containers onto trains, which is essential for efficient multimodal transportation. The operation begins with cranes or container handling machines lifting containers from trucks or storage yards. The crane carefully positions the container onto a rail car, ensuring stability. For unloading, the crane lifts the container from the rail car and places it on the ground or transfers it to another transport mode. Advanced systems and specialized equipment, such as reach stackers and rail-mounted cranes, enable precise handling, ensuring the safe, efficient, and timely transfer of containers between transport modes. The RoRo railway system is an efficient transport solution, operating daily for over 10 years. The process involves 4 key stages. Start of unloading. Specialized equipment removes empty containers from the train. End of unloading. All containers are removed, and the train is ready for reloading. Start of reloading. Containers are systematically loaded back onto the train. End of reloading. Once fully loaded, the train is ready to depart. The entire unloading and reloading process takes just 36 minutes, handling 30 semi-trailers efficiently. This system combines technology and streamlined operations, ensuring faster and more effective rail transport. The unloading process of a 30-ton container from a train involves using cranes or forklifts to lift the container, followed by careful positioning at a designated storage location. Safety protocols and precise handling equipment ensure smooth operation and prevent damage. The operation of a container crane on the M/V Icaria, demonstrating the essential process of loading and unloading containers at a port. The crane, typically mounted on rails or a fixed structure, operates by using a large arm with a spreader to lift containers from the ship's cargo hold. The crane moves across the dock, positioning itself over the containers, which are securely grasped by the spreader. The container is then carefully lifted, swung over the ship's edge, and lowered onto the dock or a waiting vehicle. For unloading, the crane reverses the process. It lifts containers from the dock or a truck, swings them onto the ship, and places them in designated storage slots within the hold. The use of high-tech control systems and hydraulic machinery ensures smooth and precise operations, minimizing delays and maximizing efficiency. Advanced safety features are integrated into the crane to avoid mishaps such as load sway and ensure safe handling of containers. This process involves tight coordination between crane operators, ship crew, and port staff. Regular maintenance and inspections are crucial for keeping the crane in optimal working condition, ensuring that each operation is carried out smoothly and safely, increasing throughput and ensuring timely delivery of goods. On the Tonsberg RoRo vessel, cargo handling follows an efficient and safe roll-on, roll-off process. Drivable, towable, and static cargo are loaded via a 12-meter wide stern ramp, minimizing crane lifting. Static cargo is placed on roll trailers and towed aboard. The ship's adjustable decks, with up to 7.1 meters clearance, accommodate high and oversized cargo. All cargo is securely lashed to vertical bulkheads, floors, walls, and ceilings to ensure stability during transit. Heavy cargo up to 505 tons and units up to 80 meters long can be stowed, utilizing internal 8-meter wide ramps and spacious main decks. Simultaneous operations across 8 decks speed up loading and unloading. Advanced design features like the bulbous bow, streamlined rudder, and turbo generator maximize energy efficiency while reducing emissions by 20% per unit. This innovative logistics process ensures safer, greener, and more efficient global cargo transportation. Euchre Car Carrier's specialized PCTC vessels use adjustable decks and ramps to optimize cargo space, ensuring safe, efficient transport of vehicles and heavy machinery. Automated loading systems streamline operations, enabling seamless delivery across global shipping routes. MG SAIC electric vehicles are shipped from China to Europe on board Wallenius Wilhelmsen's RoRo vessels. After arriving at Zeebrugge terminal, they are processed at a state-of-the-art facility offering extended PDI services, automated car washing, and painting. Once completed, the vehicles continue their journey to customers across Europe. Panama, positioned between 2 continents, is a critical logistics hub connecting major global trade routes. WWL's Panama facility at Manzanillo International Terminal includes a heavy equipment processing center and a bonded terminal, offering comprehensive logistics solutions. Upon arrival, products are received and stored securely. They undergo mechanical repairs, washing, accessorizing, fueling, equipment exercising, paint and bodywork, and quality inspections to ensure they are market ready. Customs clearance is efficiently processed, enabling distribution to over 40 countries. The hub's direct integration with the port eliminates costly trucking and re-export fees, reducing lead times and optimizing supply chains. Built with sustainability in mind, the Panama Hub features energy-efficient lighting, recycled materials, and rainwater recycling systems for washing cargo. As part of WWL's global network of over 50 processing centers, Panama provides a faster, greener, and cost-effective path to Latin America and worldwide markets. Vehicles on a RoRo vessel are secured using wheel chocks, lashings, and chains. Chocks prevent tire movement, lashings secure the chassis to deck points, and chains add stability for heavy vehicles. Crew ensure proper spacing and regularly inspect all securing systems. Vehicles are carefully driven up a wide stern ramp by stevedores onto the RoRo ship. Inside, cars are parked on suitable decks according to size. They are then secured with straps to prevent movement during transport. In industrial settings, such as warehouses, ports, or shipping yards, the process of loading and unloading goods relies on highly efficient machines and systems for handling heavy loads, ensuring productivity and safety. The operation typically begins with the receipt of cargo, whether it's containers, pallets, or bulk goods, which are first unloaded from transportation vehicles like trucks or ships. Automated systems often come into play here, where conveyors, cranes, or forklifts are used for moving items from one location to another. Once goods are ready for loading onto containers or trucks, heavy-duty lifting equipment is used. Cranes, such as gantry or tower cranes, are commonly employed to handle large or heavy loads like containers. These cranes are equipped with hooks or spreader bars to lift containers securely and transfer them onto ships or rail cars. Forklifts and reach stackers are frequently utilized for smaller cargo, maneuvering goods into position for transport. The process also involves accurate coordination to ensure that the load is evenly distributed and properly secured within the container or transport vehicle. This helps prevent shifting during transit, which can lead to damage or loss of goods. In some operations, robotic systems are integrated into the process for loading and unloading smaller or standardized items, further enhancing efficiency and reducing the risk of human error. Through these systems, loading and unloading operations are made quicker and more reliable, supporting the logistics industry in managing the flow of goods across ports, warehouses, and transportation networks. The integration of automation, advanced machinery, and skilled labor ensures the smooth functioning of these processes. The process of loading steel coils onto a bulk carrier involves a series of coordinated steps between workers, machines, and the transportation system. First, steel coils are carefully stored on the dock, ready for transport. Special equipment, such as forklifts or cranes, is used to lift and position the coils onto transport vehicles. These machines are fitted with specialized lifting mechanisms to safely handle the heavy, cylindrical steel coils without damaging them. Once the coils are on the truck or transport platform, they are carefully moved toward the ship. At the ship, Cranes equipped with heavy-duty hooks or spreaders take over to load the coils onto the cargo hold. The loading is done layer by layer to ensure balance and safety. After the coils are placed in position, workers secure them using lashings, heavy-duty ropes, and straps to prevent shifting during the journey. This step is crucial to avoid any damage during transit and ensure the safe transportation of goods across the sea. The XRS 9972 Reach Stacker is a high-performance container handling machine designed for heavy-duty lifting applications. With a rated container capacity of 99,000 pounds, 45 T, for 4 high stacking and 90,400 pounds, 41 T, for 5 high stacking, it offers exceptional strength and versatility. The telescopic boom allows for stacking containers up to 9.5 feet, 2.9 meters, making it ideal for various stacking configurations. Powered by a Volvo 12.8 liters VE 388 HP Tier 4 final diesel engine, the XRS 9972 is equipped with a Dana TE 35-speed power-shift transmission for efficient operation. The hydraulic system uses variable displacement pumps and sectional control valves, ensuring smooth operation with a joystick that can be fine-tuned for operator comfort. The Kessler D102 WHD planetary drive axle, combined with wet disc brakes, enhances durability and control. For ease of maintenance, the machine features side service doors, removable deck plates, and a Taylor integrated control system that allows for easy diagnostics and performance adjustments via a 7-inch touchscreen. Its heavy-duty steer axle, durable chassis, and wide stance provide stability, while the advanced operator cab with climate control ensures comfort during operation. The XRS 9972 is designed for productivity, with faster lift speeds, increasing operational efficiency. The new Maersk EE container ship is the world's largest, measuring 400 meters long and 59 meters wide. Designed for energy efficiency, environmental performance, and economies of scale, it carries over 18,000 TEUs. Featuring twin engines and low fuel consumption, it revolutionizes Asia-Europe trade with reduced costs and emissions. The Ram Singflex Twin 40 headblock connection system is designed for single-hoist container lifting cranes, enabling the efficient handling of single or multiple containers in one crane operation. The patented auto connector allows for a quick changeover from a single spreader to a tandem lift mode in less than 2 minutes, minimizing downtime. This system enhances container handling performance with the ability to lift twin 40-feet containers or single containers in tandem lift mode. The onboard mechanisms provide precise gap adjustment, 0 to 1,600 millimeters in 16 seconds, skew, angle, and longitudinal offset adjustments, ensuring accuracy in positioning. The advanced features of the Singflex system increase lifts per hour, streamlining port operations and improving overall productivity. The unloading of the 2,000-ton container crane from the Genoa 13 is a highly technical process that requires advanced machinery and precise coordination. First, the crane is lifted by large hoisting machines, such as a gantry crane, designed to handle heavy loads. The lifting process involves powerful lifting cables, capable of handling up to 77 tons at a distance of 40 meters. Once the crane is securely lifted, it is carefully lowered onto a platform or dock. The unloading operation may involve twin lift systems to distribute the weight evenly. Once the crane is safely in place, the lifting equipment is detached and the crane is moved to its designated location. This process showcases the combination of precision engineering, advanced lifting technology, and strategic planning to ensure the safe unloading of massive equipment. At Trepac, Los Angeles, the Calmar ASC system optimizes the handling of containers and vehicles at the terminal. Automated stacking cranes and straddle carriers work together, efficiently stacking and transporting goods horizontally. This advanced technology improves space usage, increases terminal capacity, and enhances operational efficiency, enabling the swift loading and unloading of large volumes of cargo, including thousands of vehicles, onto ships with minimal manual intervention. The tailored Texas 207 empty container handler operates with precision and power, making it ideal for handling containers in ports and yards. Powered by a Cummins QSB 6.7 liters diesel engine generating 225 horsepower, it offers outstanding performance. The 63 feet UltraView telescopic mast allows the handler to stack 7 containers with 9 feet 6 inches height, or 8 containers with 8 feet 6 inches height. The hydraulic system uses dual-acting cylinders for smooth lifting and lowering, while the Dana TC32 automatic transmission ensures efficient movement. Equipped with a side-pick container handling attachment, it provides a 24-inch side shift range for precise positioning. The handler's robust design includes a hydrostatic drive system, LED lighting, and an ergonomic cabin, offering enhanced safety and comfort for operators in various operational conditions. The Hyster H22 is a powerful container handler designed for heavy-duty tasks. The Hyster H22 container handler is designed for efficient container handling in ports. It features a Cummins 6.7L diesel engine, offering 230 horsepower and 938 Newton-meters torque. The machine lifts up to 9,000 kilograms, with a maximum height of 16,500 millimeters. The Axe-Power reach stacker operates by using hydraulic systems to extend and retract its boom arm, allowing for precise lifting and moving of containers. It uses a spreader to grip containers securely before lifting and transporting them to the designated location. The stacker's robust design and efficient hydraulic system make it ideal for high-capacity operations in ports and warehouses. The Open Top, Open Floor (OTOF) container loading system for wood chips is a highly efficient method of transporting bulk goods. The system involves containers with an open top for easy loading, typically with cranes or other lifting equipment. The wood chips are poured into the container through the top using machines like conveyors or excavators. Once loaded, the top is closed to secure the cargo. For unloading, the container features an open floor or bottom, which can be opened to release the wood chips easily. The cargo flows out naturally or with the help of automated discharge systems, allowing for fast and safe unloading. This system enhances both time efficiency and safety. The process of lifting a locomotive at Union Pacific's Worth facility involves using specialized hydraulic lifting equipment. The locomotive is first carefully positioned on supports, then gradually lifted using hydraulic jacks to ensure stability. After lifting, the locomotive is either moved for maintenance or lowered onto new components, ensuring safety and precision throughout the process. The Hubtex MQ-70 is a multi-directional forklift designed for efficient material handling in tight spaces. It uses advanced control systems for precise operation and features omnidirectional wheels for smooth movement. The forklift's lifting mechanism ensures safe handling and transportation of various goods, while its ergonomic design enhances operator comfort and productivity. The machine efficiently moves goods in all directions, optimizing warehouse space and improving workflow. Cleaning a ship's cargo hold for grain loading is a critical process, ensuring hygiene and compliance with industry standards. The process starts with manual sweeping and debris removal, followed by high-pressure water washing. Rust and residue are treated using specialized tools. Workers, equipped with safety gear, inspect areas up to 19 meters high. Machinery like vacuum cleaners and blowers assist in dust elimination. Finally, inspection teams verify cleanliness before certification, ensuring the vessel meets grain transportation requirements. This guarantees cargo quality and prevents contamination risks. At RoRo, the corn loading process is highly efficient, utilizing advanced machinery such as conveyor belts and pneumatic systems to transport corn into the loading zone. Cranes, or specialized loaders, are then used to carefully lift and load the corn into containers or ships. The equipment is designed to handle large volumes of corn, ensuring the efficient and secure transport of thousands of tons. With precision and attention to detail, the process ensures the corn is stable, well-packed, and ready for export to international markets. Trimming wheat cargo on the MV Swift involves distributing the wheat evenly in the hold to ensure stability during transit. The process uses a combination of loading spouts, mechanical equipment like bulldozers, and sometimes self-trimming systems on modern ships. Proper trimming prevents cargo shifting, reducing the risk of instability. The hold is also ventilated to avoid moisture buildup, ensuring the wheat remains safe and secure throughout the journey. The Mobile Stage Arc is an innovative mobile stage trailer designed to provide efficient, versatile solutions for outdoor events, concerts, and performances. Upon arrival at the venue, the trailer is positioned and stabilized with hydraulic supports, preparing for setup. The stage unfolds automatically using advanced hydraulic systems, creating a fully functional platform for performances. The trailer's unique arc design allows the sides to expand outward, with hydraulic arms lifting the platform and roof into place. This enables quick deployment and ensures a stable structure for events of all sizes. Once the stage is set, integrated ramps provide easy access for performers and crew. The stage also comes with built-in mounts and racks for sound and lighting equipment, making it simple to set up the technical aspects of the production. External power sources are connected to operate the sound, lighting, and visual systems, ensuring a seamless integration of all event elements. During the event, operators control the technical systems and monitor the performance. After the event, the hydraulic system retracts the stage components, and the equipment is packed away for transport to the next location. The Mobile Stage Arc combines automation, technology, and human expertise for efficient, high-quality event staging. The Caterpillar 320 CLL log loader is specifically designed for handling and loading timber, including the 9th of August 10-foot studwood. Powered by a CAT 3066T 6-cylinder diesel engine with 143 horsepower, it provides optimal lifting and handling capabilities. The machine operates with a hydraulic system delivering 205 liters per minute at a pressure of 24,000 kilopascals, ensuring efficient movement and lifting of heavy logs. With a working weight of approximately 22,000 kilograms and a swing radius of 2.7 meters, the 320 CLL can maneuver large logs with ease. Its high-speed rotation of 11.5 revolutions per minute enables quick and efficient loading operations, making it ideal for forestry and timber transportation tasks. Pine log container loading involves specialized equipment, like log loaders and cradles, to efficiently load logs into containers. Logs are carefully arranged to ensure even weight distribution, preventing damage during transportation. The process uses cranes or hydraulic systems for precise and safe loading. Log bulker is a specialized system used for efficiently loading and transporting logs. It is typically employed in the logging and shipping industries, where large volumes of logs need to be moved quickly and safely. The system consists of a robust chassis, a hydraulic crane, and log clamps designed for lifting and securing logs during loading. The operation begins by positioning the logs in the loading area. A crane or hydraulic system lifts the logs and places them onto the loading platform. Once the logs are lifted, the system's hydraulic clamps securely hold them in place, preventing movement during transport. The logs are carefully arranged to optimize space within the container, ensuring an even weight distribution to prevent shifting or damage. Log bulker's crane can handle a variety of log sizes, allowing it to be versatile for different types of wood. It uses advanced controls to offer precise movements, ensuring accurate placement and stability during the loading process. The logs are then moved into a container or storage area where they are stacked efficiently. The system significantly reduces loading time compared to manual methods, improving operational efficiency. It also ensures safety by securely holding logs in place, minimizing the risk of injury and damage during transportation. Cinnabogan 860 mobile material handler, equipped with a 3.0 square meters log grab, is designed for efficient timber handling in demanding environments. This machine is capable of lifting and maneuvering heavy logs with precision. The log grab, operated by a powerful hydraulic system, securely grips the timber for lifting, transportation, and placement. The process begins with the machine positioning itself near the logs to be handled. The log grab opens wide to encircle the timber, and the hydraulic system lifts the logs. The machine then moves the load to the designated location, such as a storage area or another transport vehicle. Once at the destination, the log grab releases the logs gently onto the ground or another surface. With its robust design, the Cinnabogan 860 excels in challenging conditions, such as log yards, ports, and industrial sites, ensuring safe, fast, and efficient handling. Routine maintenance and operator training are essential to maintain performance and safety. The Cinnabogan 870 crawler material handler is designed for efficient port handling, featuring a maximum reach of 27 meters. With energy-saving green hybrid technology, it handles heavy materials like trucks and bulk goods with precision and power. The land-based bucket ladder dredger extracts sand and gravel from wet mining pits at depths of up to 12 or 14 meters. A continuous chain of buckets scoops material from the bottom and lifts it to the surface. The extracted material is then discharged onto a stockpile conveyor. Oversized particles are separated using a screen, while the remaining material is directed to a bin for dumper loading. Depending on the model, dredging capacity ranges from 36 to 340 cubic meters per hour, with bucket sizes from 75 to 175 liters. A lifting machine in the hay industry operates through hydraulic or mechanical systems to efficiently load and transport hay bales. The system includes lifting arms, clamps, or forks to grip the bales securely. Automated or manually controlled, it ensures precise stacking and placement. Advanced models feature adjustable height, rotation, and weight sensors for optimized handling. These machines improve efficiency, reduce labor effort, and ensure safe transportation of hay bales. Operation process of a sludge suction truck action at a sand pit operated by Emil Hilge. The machine uses a powerful vacuum system to extract sand and sediment from the ground through a large suction hose. The material is transported directly into an onboard storage tank, minimizing dust and disruption. Operators control the hose with precision to reach difficult spots. This method is efficient, clean, and ideal for confined or sensitive areas. Once full, the tank is emptied at a designated location. The suction excavator significantly improves safety and reduces manual labor during excavation tasks. At Ugot Quarry, the iron ore mining process starts with powerful excavators removing the overburden to expose the valuable ore layers beneath. Skilled operators handle these massive machines, carefully clearing the surface. Once the ore is accessible, large cranes scoop it up and load it into waiting train wagons for further transportation to processing facilities. To control the large amounts of dust produced during excavation, workers regularly spray water across the mining area. This continuous dust suppression improves both visibility and safety. The entire operation is precisely coordinated, ensuring efficient extraction, minimal environmental impact, and safe working conditions for all personnel involved. The RK5000 bucket chain excavator was relocated from the CSA lignite strip mine to a designated parking site above the pit after mining ceased. The 5,600-ton machine was moved using its hydraulic crawler-mounted undercarriage, which provided stability and traction on uneven ground. Engineers and 6 operators coordinated the relocation, carefully steering the 160-meter-long structure to avoid obstacles and maintain balance. The machine's superstructure and counterweight boom remained fixed, while the substructure crawled slowly uphill. Movement was carried out gradually to prevent structural stress, with frequent checks on the hydraulic system and the 15,000-liter oil capacity during transit. The weighing and loadout of the largest and heaviest processing platform module for the Johan Sverdrup oil field were carried out at GOJ Shipyard. First, the 28,174-ton topside, measuring 139 meters x 69 meters by 72 meters, was weighed using 64 load cells placed on skid shoes. The module was then moved 55 meters using 64 skid shoes divided across 16 skid tracks. Link beams created a continuous skidding path from the quayside to the barge. Skid shoes were grouped hydraulically to compensate for barge movement, while ballasting was controlled internally and externally. A computerized skidding system managed 1-meter steps with 83 tons of push per pair of skid shoes. The skidding speed was adjusted according to ballasting conditions. Loadout positioning was accurate within 5 millimeters. The entire process, from jack up to set down, was completed within 14 hours. The coal terminal relies on stacker/reclaimer bucket wheel machines and ship loaders to handle bulk materials such as coal efficiently. The stacker/reclaimer moves across the terminal, collecting and stacking coal using its bucket wheel. This continuous process ensures that coal is stored in large piles, ready for transfer. When unloading ships, ship loaders extend their arms to scoop the coal and move it onto a conveyor belt. The conveyor system then transports the coal to either storage areas or ships for export. These machines operate with high precision, ensuring smooth handling of bulk materials. The synchronized movements of the stacker/reclaimer and ship loaders enable rapid loading and unloading, maximizing throughput and efficiency while minimizing delays, ensuring that coal is delivered promptly to its destination. A coal loading process at a mining site in Colorado. 2 trucks are seen simultaneously loading coal, demonstrating an efficient system for bulk material handling. The trucks are directed towards a large loading area where coal is lifted using mechanical equipment, such as loaders or conveyors, and transferred into the truck beds. The coal is carefully positioned to ensure even distribution for safe transportation. The video emphasizes the importance of coordination between trucks and machinery, showcasing the seamless flow of materials. This process plays a key role in the mining industry's logistical operations, ensuring timely delivery of coal to other processing facilities or transport hubs. The Senebogen 8130 EQ balancer plays a crucial role in the recycling process at Schultz Recycling. It is designed to efficiently feed the shredder by lifting and positioning scrap materials, such as vehicles and metal waste, into the shredder. The machine's high reach and precise control allow for smooth handling and processing of materials, optimizing the entire shredding operation. This enhances productivity and ensures that materials are processed accurately and efficiently for recycling, supporting a more sustainable waste management process. The Senebogen 8130 EQ balancer is utilized at Schultz Recycling in Germany to feed a shredder with scrap materials. It effectively lifts and positions large quantities of metal and vehicles for processing. This precise handling ensures a continuous and controlled feed, facilitating the efficient recycling of thousands of cars and contributing to sustainable waste management. The construction of the Alba B3 compression platform was a carefully coordinated, multi-stage process involving several locations and companies. First, the engineering and design were completed by IV Oil and Gas, with teams based in Papendrecht, the Netherlands, and Houston, USA. This planning phase laid the groundwork for the fabrication activities. Next, Construction of the Alba B3 jacket started at Hirama Fabrication Group's yard in Vlissingen. The jacket, measuring 40.3 meters by 40.3 meters and 92 meters tall, was built to support the topside offshore. Meanwhile, the topside structure was fabricated at Hirama's Zwijndrecht yard. It measured 30 meters by 39 meters by 34 meters and weighed approximately 6,000 metric tons. After the topside was completed, it was moved across the site for final inspections and loadout preparations. Once ready, the topside was loaded onto a barge and transported by sea to Vlissingen. At the same time, the completed jacket was loaded out at the Vlissingen yard. Both structures were prepared for their sail away to the offshore installation site. In parallel, the bridge and flare structures, necessary to connect Alba B3 to the existing Alba B2 platform, were fabricated locally by ECG in Malabo, Equatorial Guinea, enhancing local involvement in the project. After the structures arrived offshore, installation work began. First, the jacket was lifted and secured onto the seabed at a water depth of 76.5 meters. Then, Harima's heavy lift vessel Thialf installed the topside onto the jacket with precision. Following this, the bridge and flare were installed to complete the link between the Alba B2 and Alba B3 platforms. Thanks to the close collaboration of all teams involved, the Alba B3 compression platform was successfully installed. This achievement enhanced gas and condensate production at the Alba field, reaching 800 million standard cubic feet per day and strengthening the energy infrastructure of Equatorial Guinea. The Hirama constructed the Valamon jacket for Statoil at their yard in Vlissingen as the largest jacket ever built at the facility, weighing 9,150 tons. The construction began with the first roll-up of the top part of row 1. Large tubular steel sections were precisely cut, assembled, aligned, and welded on the yard floor. These sections were then lifted and rolled into an upright position to form the upper framework of the first row. This critical step laid the foundation for the entire jacket, ensuring correct geometry and structural stability from the outset. Following the initial roll-up, the installation of the horizontal top part was carried out. Horizontal braces were welded between the vertical legs, creating a rigid, box-like structure. Proper installation of these horizontal members was vital to resist lateral loads and to maintain the exact alignment required for the subsequent buildup of the jacket. Next, the second roll-up was performed for the bottom part of row 1. This involved the heavy and complex assembly of lower structural sections. After precise welding and inspection, these sections were carefully lifted into place and joined with the existing framework. The bottom part forms the main foundation and will bear the jacket's weight on the seabed, making accuracy in this phase essential for long-term stability. The third roll-up focused on the top part of row 5. By assembling and erecting this upper portion, the construction progressively increased the jacket's height, preparing it for the addition of cross-bracing and outfitting elements. During this phase, the tolerances of connections and alignments were rigorously controlled to prevent cumulative errors. Simultaneously, the fabrication of J-tubes and risers was taking place. These elements, crucial for housing and protecting subsea cables and pipelines, were fabricated from rolled and welded steel pipes. Once fabricated, the J-tubes were subjected to thorough quality checks to ensure their strength and corrosion resistance. After fabrication, the J-tubes were installed into the bottom part of the jacket. Precise alignment was necessary to ensure correct routing of pipelines during offshore hookup operations. Special supports and guides were fitted to integrate the J-tubes seamlessly into the jacket structure. The next major step was the installation of the cross braces of row A. Cross braces, assembled from tubular sections, were positioned and welded to enhance the jacket's resistance to environmental forces, such as waves, currents, and wind loads. Their correct positioning was essential to distribute loads uniformly across the structure. Meanwhile, the fabrication of the wellhead module was progressing. This module was built separately, involving the assembly of a strong frame equipped with connection points for drilling and production facilities. Its compact and robust design allowed it to be easily lifted and integrated later with the main jacket structure offshore. As the fabrication activities drew to a close, preparations for the loadout phase intensified. Temporary support structures, skidding tracks, and sea-fastening devices were installed to facilitate the safe movement of the jacket. The massive structure was slowly transferred onto a heavy transport barge using synchronized hydraulic skidding systems. Finally, after securing the jacket on the transport barge, the sail-away phase commenced. The Valamon jacket departed from Vlissingen and set sail towards its offshore installation site, marking the culmination of months of meticulous fabrication, inspection, and project coordination. The Senebogen 830 mobile material handler plays a crucial role in the scrap handling process at Sims Metal Management in the UK. Its primary function is to efficiently load scrap material into various processing equipment, like shredders and balers. This mobile handler's flexibility and high lifting capacity allow it to handle large volumes of scrap, including vehicles and metal waste, with precision. The machine's hydraulic systems are designed to provide smooth and controlled lifting movements, ensuring that scrap materials are placed with accuracy into the shredding and baling machines. These machines are essential for reducing the scrap into smaller, more manageable pieces or compacting it into bales for easier storage and transport. The Senebogen 830 Mobile's ability to move between different processing lines optimizes the workflow, reducing downtime and increasing productivity. Additionally, its advanced safety features, such as anti-collision sensors and stable tracking, ensure safe operation in a busy environment. The integration of this handler within Sims Metal's operation ensures that scrap handling and recycling are carried out efficiently, supporting the company's sustainability efforts and reducing the environmental impact of waste materials.